you were asked to picture the world's largest treasure, you might imagine a large vault filled with chests of jewels and gold. But the world's largest and possibly most important treasure is buried right beneath our feet. Soil holds massive amounts of organic matter, which increases its ability to store and release the nutrients essential for plant growth. Soil organic matter also increases soil porosity, allowing it to store enough water and air for plant roots. This means soil organic matter forms the basis of soil health and fertility, and so food production. But it carries out another crucial function. It captures carbon from the atmosphere as soil organic carbon. Plants fix organic carbon in soils through debris, roots, and fluids. Soil fauna break down these residues into soil organic matter. Some of this organic matter remains as soil organic carbon. Some is naturally released into the atmosphere as carbon dioxide. It is when we lose soil organic matter through human activities that we face problems. The degradation of 1/3 of the world's soils has already released up to 100 gigatons of carbon. Yet an estimated 1,417 gigatons remain in the first meter of soil across the globe, almost double the carbon in our atmosphere, and dozens of times the levels of man-made emissions each year. It is clear that losing the soil carbon treasure would increase carbon emissions and accelerate climate change. But we can do something about it. Many physical and biochemical mechanisms protect soil organic matter from decomposition. Soil management practices influence these mechanisms and can bring carbon gains or losses. Since soil organic carbon is highly dynamic, we need to find innovative ways to sequester more carbon by adapting strategies to local conditions. We also need to monitor and report changes in soil organic carbon. And we need to maintain soil organic carbon stocks in vulnerable hotspots. Peatlands, permafrost soils, and black soils are particularly prone to carbon losses. Grasslands store more than double the amount of carbon in all other agricultural areas. Drylands are important because although they have low carbon content per square meter, they cover a large surface area. Scientists have already demonstrated the many sustainable soil management practices that can preserve and boost soil organic carbon. Governments now need to support land users to implement them. This is a huge task, but an even bigger opportunity. We can enhance resilience to extreme events. We can restore soil fertility to provide cleaner water and nutritious food, and preserve terrestrial biodiversity. And by rehabilitating the world's degraded soils, we can remove up to 51 gigatons of carbon from the atmosphere. There can be no doubt that joining forces to protect and increase the stocks in the soil organic carbon treasure represents a sound investment in fighting the most challenging environmental issue of our time, our changing climate. Soil organic carbon, unlocking the potential of mitigating and adapting to a changing climate.